So in the last video, we looked into how to expand algebraic expressions using distributive law. We called it the linear expansion. If you haven't watched that video, I highly recommend that you do so, as this is a continuation from that video. You can find that video on the top right corner of your screen or in the description below. So in today's video, we'll be looking into factorization. Now factorization, as I had mentioned in the previous video, is basically the reverse process of expansion. For example, if you have a look at this question, 2x times 3y plus 5, and in this example in the last video we expanded this to this answer over here. Now what factorization does is it basically reverses the process, which is to undo what was done by expansion. So in factorization, what we'll be doing is we'll be finding a way to put the expanded expressions back into their bracket form. So if we take this same distributive law example here, the process of going from a times b plus c within brackets to ab plus ac from here to here, this is what we called as expansion. In factorization, we'll be given with the expression of the format ab plus ac, where we'll have to take it back to the form where it is within the brackets. This is called factorization, and particularly in this case it's called linear factorization because we just reversed linear expansion. So let's have a look at these examples. Let's start with the first question, 9y plus 12. So to put them back to brackets again, we need to identify what we call as the common factors in this particular expression. Now when I say common factors, that common factor could be a number or even a variable. So the way we basically identify a common factor is observe both the terms individually. So the first term is 9y and the second term is 12. We can observe that one of the terms have a variable and the other term does not have a variable. So the 9y has a variable y in it, and the term 12 is just a constant, it doesn't have any variable. And therefore there is no common variable within these two terms. So then let's focus on the numbers 9 and 12. If you take 9 and 12, we understand both of these are from the 3 times table, which means the number 3 is a common factor for both 9 and 12. So therefore I can factorize 3 out of it. So what do I mean by factorizing 3 out of the expression is that I can write 3 as something common outside, and then whatever that is remaining of these two algebraic terms, I can write those inside the bracket. So in this case, if I take 3 out common from the term 9y, so 9y can be interpreted as 3 times 3y. So if you take this 3 out common, that 3 is not there anymore in that algebraic term. So what remains is this 3y. Likewise, if you take 12, 12 can be interpreted as 3 times 4. Now since I have taken this 3 as a common factor outside, what remains is just the 4. And it should be plus 4 because it's a positive number. And this is how we factorize. So this is the factorization of 9y plus 12. That is 3 times 3y plus 4. Now you can think about factorization as this method that I just showed here, or you can think of it as a division as well. So you can think about it like this. What number can divide both 9 and 12? So 9 and 12 both can be divided by 3. So you take 3 out. If you take 3 out, 9 divided by 3, that's a 3. So that remaining 3 will come inside. And then 12 divided by 3 is a 4. So if you want to think of factorization as basically finding a common divisor, you can think so as well. You can say 9y divided by 3, I get 3y, then 12 divided by 3, I get 4. Or you could think about the way I did here. You can think of 9y as 3 times 3y, and therefore when I take 3 out, I only have another 3y remaining. And also 12 is 3 times 4. If I take 3 out, I have 4 remaining. Either way, whichever the way you think, it's going to be the same thing, so it doesn't matter. And if you want to verify if this factorization is correct, expand it again and see. So let's expand it and see. 3 times 3y, that is 9y. 3 times plus 4, that is plus 12. So we see we get that same expression that we started with, and therefore this factorization is correct. So we can use expansion as a way to verify if your factorization is correct. Alright, so let's look at question number 2. 5x squared minus 7x. In this case, if you observe the numbers 5 and 7, we understand that there is nothing common in 5 and 7. 5 and 7 are both prime numbers and therefore they don't have any common factors. So there is no number that is common for both the algebraic terms. However, the variable is common for both algebraic terms. Both of them have x. So let's take the variable x out. Now if I take the variable x out, I can think of 5x squared as 5x times x. And if I take x out, that means what I have is just 5x inside. Now again, we can think about this as a division as well. So 5x squared divided by x, 5x squared divided by x, that is just 5x, because there is 2x on the top and 1x at the bottom, and that 1x at the bottom will cancel off with one of the x's at the top, so just leaving 5x here. And similarly for 7x, if you do the same division technique, 7x divided by the outside letter that you just pulled out, x, this is just 7 because both the x's cancel out each other. Or you can think of 7x as 7 times x, and since we pulled x as the common factor outside the bracket, what remains is a 7, and this has to be a negative 7 because it's a negative here. And again, if you want to verify this factorization, you can expand the answer to see if you get the same expression again. Okay, so now let's have a look at the third question. 6x squared plus 12x. You can observe that the common factor can be found both in the coefficient and in the variable. So first let's look at the coefficient. We have 6 and 12 and they're both in the 6 times table, which means 6 is a common factor or a common divisor. And from the variables, it's clear that x is the common factor. Now to find what falls inside the bracket, you can use either of the two methods. I'm going to go with division. So 6x squared divided by 6x. 6x squared is the term that we have here in the expression. Divide by what we just pulled outside. Divide by 6x. We clearly see 6 will cancel out. X squared divided by x. Couple of videos back we learned the laws of indices, in which I clearly explained how to deal with this kind of problems where you have to divide a variable by another. So if you have struggles with that, I recommend that you watch that video. I'll put the link to that video in the description below as well. So x squared divided by x is just x, so that x will come here, and then this plus sign. Then we have 12x, that being divided by 6x, so 12x being divided by 6x. When you divide 12x by 6x, the x terms will cancel off. 12 divided by 6 is just 2. So that is 2. So the final answer is 6x within bracket x plus 2. Alright, so now that we've done 3 questions, I want you guys to pause the video and try out question 4 and question 5 by yourself, and then resume the video to see how it's done. Alright, I hope you guys tried 4th and 5th question, so let's discuss that now. Question number 4. 5g squared h plus 10hj. First of all, let's focus on the numbers. The numbers are 5 and 10, and clearly 5 is the common factor, as both 5 and 10 are from the 5 times table. So I can take the number 5 as a common factor outside, and from the variables I see h as a common factor. Both of the algebraic terms here have the variable h, so I'm going to take that h outside as well. So now the remaining terms will come inside the bracket. So the first term, it's 5g squared h, 5g squared h. So I'm going to divide 5g squared h by what I just pulled outside as a common factor, 5h. 5 and 5 divides each other, it cancels off. H and h cancels off. What's remaining is just g squared. Now you don't need to necessarily show this working, or you don't need to necessarily do this each time. The reason why I am doing a division here is for you to easily understand how it actually works. But when you're actually doing the question, you can just do this part mentally. Alright, so plus, and the second term is 10hj. And when you divide 10hj by 5h, 10 divided by 5 is 2hj. You took the h out, so that's just j remaining. That's the final answer. You can also do this same way like I did earlier. 10hj divided by 5h, and then 10 divided by 5 is 2, h cancels off, that's 2j, right? So you can still do that, but I just showed you that it is not necessary that you write that down every time. And if you're able to do it mentally, you can do so, as that is a little faster. Alright, so that's the fourth question for you, and the final question is 2 pi rh plus pi r squared. So let's figure out what are the numbers or variables that are common in these two algebraic terms. We understand pi is common, so I'm going to take pi outside. R is common as well, so pi is common, and then r is common, so it has r, and r squared also has r in it, so r is common. Open brackets. 2 pi rh. If you've taken the pi and r out, you can see I've color coded them. What is remaining is just 2h. Plus, if you've taken pi and one of the r's out, you only take one r out, so there's another r remaining because it's an r squared. That is 2h plus r. Hope you understood the idea behind common factors and how to use them to factorize algebraic expressions. If you found this video useful, hit the like button and subscribe for more videos, and leave a comment below if you have any questions or if you have any topics that you want me to discuss in the future videos. See you in the next one.